iTM is a test framework comprising a set of defined and documented processes and procedures based on well-known standards and proven best practices. As part of test monitoring and control, iTM defines a number of key performance indicators, which, if used sensibly and interpreted correctly, will provide an accurate picture of the effectiveness and efficiency of the test process throughout the software development lifecycle, without overly burdensome data capture procedures. iTM defines, in its data catalogue, what data items should be collected, and also indicates where they should be collected, by means of metrics touchpoints associated with process steps. iTM also provides a test metrics tool, a powerful and comprehensive means to collect and report on KPI-related data, providing information to allow not only individual test projects, but also the test process itself to be monitored and controlled. Over the next few minutes, we're going to have a look at the main reporting features of the metrics tool, using data from a real project. The iTM metrics tool provides a one-stop shop for all data items and related key performance indicators needed at test project level. The tool provides the ability to capture and report progress against plan on test preparation, test execution, and overall test effort. The test preparation progress dashboard shows at a glance the number of test cases, scripts or procedures that are needed, the dotted line, and the progress made in drafting, the solid blue line, and having them signed off as ready for execution, the green line. The black line is an indication of when, based on current progress, all scripts will be ready. There's a similar graph for requirements coverage. Should you need to see the data in more detail, larger versions of these graphs are available. Up to 3 test levels may be tracked simultaneously in one instance of the tool. Here we are tracking only one test level, which we have decided to name System Test, but the names and types of levels tracked are customizable by the user. The Test Execution Progress dashboard enables at-a-glance historic trends of the execution and pass rates of test cases, scripts or procedures. The planned execution rate is shown by the dotted line, and the actual number of unique test cases run is shown by the solid blue line. The number that have passed is shown in green, with the forecast pass estimate in black. Once again, larger versions of these graphs are available. The graph to the right-hand side of this dashboard shows execution of scripts including retests. The difference between the planned, dotted line, and actual, solid line, represents the amount of rework due to defects and other factors. The Test Effort Progress dashboard provides information regarding how well milestone targets are being achieved, and how the overall planned test effort relates to the actual effort expended so far. The effort for different test phases is tracked and reported as variance from the baseline plan. Interpreting the 3 distinct types of data presented here can provide valuable information regarding estimating accuracy and the ability to control test resources. The tool also provides a number of graphical and tabular representations of the quality of products under test and of the effectiveness and efficiency of the test process as indicated by the status of defects. The dashboards displaying these data include a comparison of numbers of defects open and closed, analysis of defect status by severity, priority, and times reopened. One of the more important analyses in terms of demonstrating the effectiveness of testing is defect leakage. The defect leakage dashboard shows in which test levels defects were actually discovered in relation to where they originated. The green band in the middle of the table here is where, in an effective test process, defects would be expected to be detected. Defects detected outside of the green area indicate an amount of leakage into later phases of the test life cycle. Obviously, any defects found in production are a bad thing and need to be investigated. Another important set of data that the metrics tool provides is an analysis of the cost of defects. As should be obvious, the cost of rectifying a defect increases substantially the later in the life cycle it is detected. By entering in the data control section of the tool the amount of time and monetary value that a defect costs to rectify at different stages of detection, the full cost of dealing with all defects can be estimated. iTM supports the principle of shift defects left and compress. In other words, not only find defects earlier in the software development lifecycle, but also compress the defect curve by reducing the overall error injection rate, so there are actually fewer defects to find and fix overall. The shift-left defect reports show the potential impacts of the iTM defect prevention process on earlier defect detection and the financial and time savings this could bring. The shift-left defect leakage report identifies the change in the numbers of defects detected at various test levels based on a certain percentage of all defects being detected at one test level earlier in the life cycle. The expected percentage able to be detected earlier is set by the test organization based on historic analysis or experience. Here it is 20%, but this can be overridden to perform a sensitivity analysis if required. A related report is the shift-left defect cost report, which shows the estimated cost saving brought about by the earlier detection of defects. This could of course also be represented as a time saving or a risk reduction by allocating saved time to extra testing. This defect dashboard shows the defect detection and fix analyses categorized by test level and severity, with numerous associated defect detection and defect fix percentages. And finally, for defect-related reports, there is the defect aging report, showing how long it took for defects to be rectified and how long unresolved defects have been outstanding. The metrics tool enables other test-relevant measures to be collected and reported, such as the stability of requirements and the effectiveness of the review process, both of which feed into key performance indicators. All metrics tool dashboards are designed to be able to be copied and pasted or automatically linked into standard test reports to make reporting easier, simpler, and more standardized. The analyzed data from the whole of the tool is used to feed the key performance indicator dashboard. This provides a numeric value in combination with a red, amber, green display to visualize the achievement of predefined KPI thresholds. For each defined KPI, there is a section in iTM providing guidance on what the measure means and how to interpret the information if its status is other than green. While each KPI on its own will provide information, using the KPI outputs in combination can also provide insights into the testing process, product quality, and overall efficiency and effectiveness of the test process. That concludes this introduction to the iTM metrics tool. If you would like to know more about the tool, or about iTM in general, please contact Experimentus. The details are on the screen now.